Okay, so today we'll be discussing with Natasha. Natasha, she is a second-year PhD researcher, and she will be talking about AI and cybersecurity for automotive. So, hi, Natasha.
Hello, everyone. I'm very glad to be here with you today, and I would love to share with you my experience regarding the application of artificial intelligence to automotive cyber attacks. Maybe we all know about the application of artificial intelligence to the usual cyber attacks in computer networks. So today might be a bit special since I will be showing you how we can leverage these artificial intelligence techniques for the automobiles, which means for the automotive cyber attacks. Okay, so who am I first? For those who do not know me, I'm Natasha Alkhatib. I'm a second-year PhD student. I'm currently having my thesis at Institut Polytechnique de Paris, which is a French research institution known in France and internationally. I'm part of the academic team of the research chair Connected Cars and Cybersecurity at Telecom Paris in Lab LTCE. We're currently having a partnership with Renault, Wavestone, Valeo, and Thales. So, okay. Today, as I told you, we're talking about artificial intelligence applied to automotive cyber attacks. But first, you may wonder, why do we have automotive cyber attacks? What's the thing that might trigger having cyber attacks inside of the car? Are there any weaknesses? Since you know, we can have cyber attacks on computer networks or on operating systems or on any system that may have vulnerabilities. So the big thing that triggered these automotive cyber attacks is having the cars being connected. So recently we're having a sharp rise in consumer demand for digital connectivity and their associated functions in the automobiles. So as you know, we may have each one having a car can see we have a lot of embedded electronic systems inside of the car, whether we're talking about the sensors, the actuators, the control units. For example, you can see we have camera, we have LiDAR, we have different controlling units which are designed to ensure the functioning of the vehicle. I mean, like improving the performance, having some parallel parking in the car, by the car, and anticipating functions. For example, if you can make some diagnosis of what's happening inside of the car. Beside that, we also have embedded electronic systems that are considered as communication systems. So now you can just open your phone and connect it to your infotainment system in the head unit of the car just by Bluetooth or by NFC or even by Wi-Fi. And even more than that, we will be deploying recently in like by 2025, V2X, V2I, and V2V. Does anyone know about this communication? Have you ever heard about V2X, V2I, V2V? Okay, some of you know, so it might be easier for me. I would just introduce you to these kind of connections so that you can grasp some idea related to these connections. Today we have 3 types of connections, and as I told you, they will be deployed by 2025. So we have short-range connection like Wi-Fi, Bluetooth. You do not need that long range for these technologies, whether you want to connect your phone to have some music played on the infotainment system, or just like watch some video while being in the car. And we have also long-range connections, like the car can now integrate a SIM card inside its network, so you can have 2G, 3G, 4G connection of the car with its surroundings. And beside that, we will have new connections, which I have already mentioned, like the V2X, which is the V to everything, like the vehicle to everything, we will have the vehicle to infrastructure and vehicle to vehicle communications. So you can see we're having a lot of communication systems embedded inside of the car because of this sharp increase demand by the consumers. And this communication system will actually help car manufacturers to provide, for example, potential types of services. Like if you want to have this smart city and make some traffic flow analysis, you're able to do so by leveraging these kind of connections. Your driving might be enhanced by having navigation services, roadside assistance, and many other services which I have listed here in the slide. However, there's a huge problem. Since you know that the more we have this, the more we're having this vehicle transforming from closed system to an open system, the more we will have attacks, the more the attacker will be able to exploit weaknesses in the communication system, in the Bluetooth, the Wi-Fi, the NFC. So in this case, we will have a lot of vehicle functions that are being manipulated. So if we start by the window lifter of the car, to the signal horns, to the indicator lights, to the displays, and to even more safety critical functions like the vehicle acceleration or the brake or steering activation when you're driving. So, and even the light manipulation. So this is very, very tricky. So we will have a property damage and personal injury in road traffic. I do not know if you have ever heard about the famous remote exploitation of 2014 Jeep Cherokee. So this was something very terrible. Like on summer 2015, we had two well-known attackers called Charlie Miller and Chris Valasek. And these two hackers were able to hack the car remotely. So the car was driven on a road by a journalist from Wired magazine, and they were able to compromise the Jeep Cherokee via a vulnerability in Uconnect. So Uconnect is actually a vehicle internet connected entertainment system inside of the car, inside of the infotainment system. And once they were able to hack this infotainment system, they actually started to change how the vents were, what the vents were doing. For example, the vents started blasting cold air at the maximum setting. The radio was on full volume, and the windshield wipers turned on. So all at once, they made this to the Jeep. And as you can see in this photo, look at what happened to the Jeep. So it's really terrible.
So, but hopefully there was no injury, right?
Yes, because they have planned with the journalist that they will do some attacks. So hopefully nothing happened. Only the Jeep doesn't work. So it's a property damage. Personal safety is guaranteed. So actually, what Miller, the hacker Miller said that we sent the Wired reporter Andre to the highway, and then we killed his engine, essentially. So as you can see, this is really terrible. And okay, we're having a trade-off between having the car being connected and a trade-off, like the car, okay, is being connected. We're actually having a lot of services inside of the car. The driving experience is enhanced, but the part which is very bad is that we are having some weaknesses inside of the car, and attackers are able to exploit these weaknesses and to attack the car. You can see we have a lot of type of cyber attacks. So if someone is interested in hacking, you might know that there are spoofing attack, there are tampering attack, repudiation attack, information disclosure. Okay, so maybe it's not a big deal. Actually, it is a big deal to have this property damage of the car. But what if there's a passive attack, which means that you have your car currently collecting a lot of data about you, because it's being connected, and the attacker might be passive and just listens to where you are currently going. It has the Google map, so it knows everything about you. So this is, for example, information disclosure, and there are a lot of different attacks. So we must be a bit afraid, like a lot afraid. In order to guarantee this personal safety, cybersecurity now is considered as a new dimension of quality for automobiles. So each car manufacturer must have the cybersecurity as the main, like, it's not a dimension, it must be the main dimension, since the car must be connected for the quality of the manufactured automobiles. And because of this, I am, like, with this motivation, I have chosen this thesis. So that's why I'm doing my PhD currently in the implementation of an intrusion detection system based on artificial intelligence and like basically on deep learning to detect attacks inside of the car. Have you ever heard about an intrusion detection system? Like for some of you who are familiar with the cybersecurity terminologies, in order to secure a network, like a network connecting different systems, we can implement something called intrusion detection system. It is actually a security measure for computers. And for sure, this intrusion detection systems can be deployed inside of the network. So it monitors all the internet traffic, all the packets that are being sent and received by different clients and servers and different systems, actually. And the more our intrusion detection system is able to detect these attacks happening inside of the network and to have a low false alarm, which means it also can analyze the normal behavior well and doesn't misclassify the normal behavior for as being abnormal behavior. So the better it is. So that's the main aim of an intrusion detection system. Like, we can evaluate the performance of this intrusion detection system by these two evaluation metrics. And there are different types of intrusion detection system. It all depends on the placement. Where we want to put it inside of the network? Should we put it in the network so it can receive all the packets in the network, or should we put it on a client so it monitors the inbound and outbound packets for a certain client? And the other division for the intrusion detection system is the methodology. So how does it detect these attacks? And in my thesis, I'm detecting these attacks by leveraging artificial intelligence. So you can see here in this picture, we're having this intrusion detection system being placed inside of the network, but it's not placed at a certain system. So it monitors all the traffic in the network. And through my thesis, I'm implementing this kind of intrusion detection system, which is a network-based. Okay, so now the part that matters for us the most, which is the leveraging of deep learning in our system. Actually, there are, as you know, different training approaches to use in any artificial intelligence based or deep learning based problem. So we might train our data using the supervised approach, using the unsupervised approach, using the semi-supervised approach, or even the reinforcement approach. But I did not put it here because in the intrusion detection system, we still did not have these systems for the automotive cyber attacks. So regarding the supervised, as you all know, we must have a labeled data set. So you can see that if we want to adapt this supervised, we must have this labeled data set. Okay, so after having our data set, we must pre-process it, and then we must train it so that the algorithm learns. And then after learning, our algorithm must classify the traffic between ban-in attack or ban-in behavior or attack behavior. So it's normal or abnormal behavior. Okay, so all of you know that we might have different architectures of deep neural networks. So we might have the multiple layer perceptron, or we might have the convolutional neural network, or the recurrent neural network, and diverse other architectures. In my case, I have used the recurrent neural network because memory matters in my case. I need memory to to have information from the whole traffic, like in the past events of the traffic, so that the algorithm learns well. Okay. What I'm currently facing. So all of you know that dataset is the fuel. So if you want to create an intrusion detection system which works well, you must have a dataset that covers all kinds of attacks. And it must be labeled since we're using the supervised approach. However, currently there's a huge lack of automotive intrusion detection datasets regarding the Automotive Ethernet protocol, which is the protocol that connects different systems inside of the car. And it's actually used currently in nowadays cars because it has a high bandwidth, and it can support great functions for the car, like the ADAS system, like the adaptive cruise control, and other advanced functionalities of the car. However, as I told you, there's no data set in this field, so this is the big problem we're currently facing. That's why through my thesis, I have generated this data set, which is a data set based on Automotive Ethernet. And after generation, you can see in the photo here that I have preprocessed it. I have labeled it, like it was a manual labeling. And then I have grouped the sequence of packets that belong to the same session. And I have labeled each sequence of packets if it's normal or if it's abnormal. So after, you can see, like, now that we have preprocessed the data and it is labeled, it can be fed into the recurrent neural network system. And then the recurrent neural network system will be able to detect if this is a normal sequence of packets or if it's a abnormal. Learning can be when being applied to, when actually being embedded into an intrusion detection system. We have found that there are 4 main neural network architectures that can be created for our work. You can see them in the table. I won't get into the details much, but we have realized that we had great accuracy for the overall proposed sequence model. We had low false alarm rate, which are the low false positive rate. And we had low misdetection rates, which are the false negative rate presented in the table. And we have applied early stopping so that the model doesn't overfit. So as you can see, we had some great results until now. Okay, and actually, this was the novelty of our work. We have generated like as I told you in this slide, there was no data sets for Automotive Ethernet, so we were the first to generate this Automotive Ethernet data set with intrusions and without intrusions. We were the one who labeled the data set, and we have actually had made some hyperparameter tuning to check the great sequence model with good performance. So we have found that the RNN and LSTM were actually doing some good work. And besides that, we have found also that it can be implemented in real time, since the inference time per input was 3 milliseconds, between 3 milliseconds and 7 milliseconds. So it was very good in our case. And yes, thank you for watching this presentation. I'm very glad that you have watched it. If you have any questions, please let me know. And thank you.
Thank you, Natasha, for your presentation. Do you have any questions for Natasha?
Yes, I have one. Thank you, Natasha, for the presentation.
Thank you, Chadi.
Yeah.
Thank you, Iman. Thank you, Ahmad. Thank you, Lina.
Yeah. So one question. So I guess you labeled the data, right?
Yes. As I told you here, like this is the photo where I am showing you different phases of labeling.
Yeah. Yeah. So my question: what really defines an abnormal packet? So you said like we have like normal packets and others that are not. So during like labeling, so how you decided like this is normal, this is not?
Okay, this is a nice question. The thing is that as I told you here in this slide, let me show you. Okay, so there's a, no, not in this slide. Okay, so if you investigate the security weakness in like the external communication interface or even the protocol, like we have worked in our thesis on the application layer protocol of the OZ layer. So if you can investigate the security weakness of some of the application layers of the OZ layer, you can create attacks based on these security vulnerabilities. So we did some, let me call it reverse engineering. What we did actually, we have read about the documentation of a specific application layer, protocol, the Automotive Ethernet. And we have found that there are certain vulnerabilities in this protocol. So, after verifying that these are urgent vulnerabilities, we have tried to make attacks on this application layer protocol, and we have collected the data set for this for the traffic of the normal traffic of attack and the abnormal traffic of attack.
Okay.
So yes.
Yeah,
so
okay.
It's related to the application layer protocol.
Yeah, I see. Okay, thank you.
I have questions for you, Natasha.
Yes.
Yes. So my first question was the same as Chadi's question about the labeling of the data.
Yes.
The second one is that have this algorithm been used in other security scenarios, not only for the cars?
Exactly. So actually, we got inspired by the network intrusion detection systems, which are based on deep learning, but in computer networks. So we have made, yes, exactly. So we have made a survey regarding what kind of deep learning architectures are being applied to detect intrusions in general network and computer networks. And we wanted to verify that these architectures work well also for the automotive network.
Okay, and did you look at other works, other security algorithms in the cars that they are
yes
existing?
Exactly. We have found that, for example, also convolutional neural network, which is usually applied to the classification of images and for the classification of videos, can also be applied in our case on the network traffic, just by converting network traffic to images. So if we convert network traffic to images and then we feed these images, these images to the neural network, it can predict if this image, which is a collection of packets, is actually a normal or abnormal image.
Okay.
But we still didn't apply it. We will hopefully apply it in later contributions.
Yeah, but I mean, there are other people that they work on security algorithms for connected vehicles or for cars.
Yes, okay, exactly. But I will clarify this. Usually in the car, we have two types of networks. We have the in-vehicle network, which is responsible for connecting the electrical units inside of the car. And we have the inter-vehicle network, which means like the connection between two cars. This is another network. What we are focusing in our thesis is the vehicle inside of the network, not the one outside of the network. So there are a lot of people that have implemented the security algorithms, but they have applied it on a traditional protocol, which is called CAN protocol.
Okay.
So our contribution is very efficient and is novel because no one has applied yet machine learning on automotive Ethernet protocol. That's the novelty in our. There's only one person that have recently published his work now. He has published a journal regarding applying it on using convolutional neural network and AVB protocol inside of the car for the videos and the images.
Okay. And just a final question. It's a general question, maybe because I'm not involved in the security topic. If for some reason an attack entered the car, because you said that your algorithm achieved 99 point something, so there's still a small risk if we have a brilliant attacker that maybe the car will be attacked. So what happens next? Is there a defense algorithm against this attack, this kind of attack, or you're not interested to look at what happens next?
Yeah, very nice question. Very nice. System and intrusion prevention system. So we have actually, they leverage two systems which are complementary. So once the attacker, the intrusion detection system detects an intrusion, it tries to prevent the attacker from performing its operation inside of the computer networks. For intrusion prevention system, it's another thesis, but I will tell you from what I have read regarding these systems. They have to make the driver aware. They have to make the driver aware by doing things that will not make him afraid. For example, if you vibrate something inside of the car just by letting him know that, okay, there's something urgent, you have to stop the car. So, but there are mechanisms that must be applied, but they must be safe mechanisms. So the car manufacturer must be really responsible for doing so.
Okay, it's clear. Thank you.
Thank you.
Yeah, hello, Natasha.
Hello, Ahmad.
Thank you for this fine presentation. It was very good and a good introduction for maybe a combination between machine learning and cybersecurity. Just have one question because you mentioned that in your, let's say in your field, you don't have a lot of resources for data sets and you had to simulate new data sets. So my question is, because we know that when we simulate the data set, we are trying to, as much as we can, to simulate the real data. So what could be some challenges you might find in some real data if you have more resources of real data?
Yes. So in simulated data, it's more it's a bit close to the practical data, to the real data, but with more with less complexity, as you mentioned. Regarding the real data, we might have a lot of noise. We might have a lot of traffic that doesn't reflect the real, doesn't reflect something important or necessary happening that we want to take into consideration. So we have to take into consideration this thing. And another thing, it's also we have to imagine a lot of scenarios regarding the real car. And we must have a lot of human resources actually for driving the car, and we need also like it's easier to work on a simulated data set and to create attacks which can be really dangerous than to work on a real data set and to create dangerous attacks. Like if you want to break the car on a highway, it's really dangerous to do so with a real car, but it's easy to do with something simulated.
Yeah, I get you. Thank you.
Yes, thank you for asking. It's muted.
Yeah, I may have also one question. You said that you have labeled your dataset, and also you are using a supervised approach for the deep learning training. So my question is, if you have a supervised approach with a classification, so you have a limited number of attacks that you are defining first, is a deep learning approach able to detect an attack that was not defined like in your labeled dataset?
Okay, so also this is a really good question. Okay, in order to detect unknown attacks, like attacks that are really unknown, which the algorithm did not work on did not learn about during training, we must implement unsupervised learning. Because, okay, supervised learning is good, but it really looks a signature-based intrusion detection system where, like, intrusion detection system might have a data set of the signature of each attack. So if you want to create an anomaly-based intrusion detection system, we must work on unsupervised to detect unknown attacks. Okay. So we must have the data set unlabeled, and it must study the probability distribution of the normal behavior. And for traffic, network traffic, which is different from the normal behavior, it must flag, okay, there's an attack here.
But I mean, if the model have already learned that here, for example, there's 5 known attacks, what if we have applied the new attack and in some way we tried the model to be more general? So it's not like unsupervised, but it's supervised with some knowledge about here. It's not related to only the normal behavior, but it can be generalized from what we have already known. So in some way, we can say that this is an attack, but we don't know what is the type of this attack.
The trick is how you create the data set. So if you create a data set by listing all the traffic that represents the normal behavior, then at a certain point it might be true, like because it knows all the behavior related to the normal, to the normal traffic. But I prefer applying unsupervised in anomaly detection.
Okay, yeah, sure.
Okay. Are there any more questions? Okay. So, guys, I'm glad that I have introduced you to the field, and I have made you a bit aware of what's happening. And I hope you can choose a great car with the cybersecurity features so that you can guarantee your personal safety and do not damage the property you have. Thank you.
Thank you, Natasha.